substitute לפרנטי, ואם יש אורחים אחרים שדוברים אנגלית, אז גם שהם ידעו שאנחנו רק בהתחלה מדברים קצת, ולאחר מכן הבמה תהיה באנגלית. Dear František, we have started the meeting and we have the pleasure to host you in this webinar in which you will present your philosophy and Eaton's philosophy related to fire protection, fire mitigation due to and in electrical installation. I have seen your presentation, that is an excellent one. Also, you are aware that part of the attendees will ask you questions and the round table will be open close to the hour 6 before one quarter of hour before 6 in order to give enough time to others to ask you questions.
Yep.
We have a little bit, now I will switch again to Hebrew in order to introduce your company, well-known company, and afterwards I will introduce you again with all your titles and position and responsibility, so you will be, afterwards you will start presenting your presentation. בהיעדר המנכ"ל של החברה, שהיה אמור לשאת כמה דברי תודה, דברי ברכה, אופיר גורן, ה-CEO של איתון ישראל,
סרג'ו, אני הצלחתי להצטרף. אני פה.
אז יש לי את הכבוד להציג את החבר הטוב שלי מזה כבר 30 שנה, את אופיר גורן, מנכ"ל חברת איתון ישראל.
אוקיי, אז ממש קצר כדי לתת זמן להרצאה. ברוכים הבאים להרצאה של איתון, אני מקווה שתהיה ראשונה בסדרה. אנחנו רוצים להביא את המומחים העולמיים, אם אפשר שכולם יעשו מיוט, כי שומעים אתכם. אני מקווה שזו הרצאה ראשונה בסדרה שבה נביא מומחים מהשורה הראשונה שעובדים באיתון, כל אחד מומחה בתחומו. כמה מילים על איתון. איתון חברה גלובלית, אתם מכירים בטח את השורשים, את קלוקנר מילר, שאחר כך הפכה להיות איתון. חברה גלובלית עם היקף מכירות של 25 מיליארד דולר. הנוכחות שלנו בארץ חזקה, בעיקר אצל בוני לוחות, בוני מכונות. אני חושב שכל האנשים פה מכירים אותנו. במידה ואחרי ההרצאה תרצו לשאול שאלות את הצוות שלנו, אז אתם יודעים איך למצוא אותנו. ו-without any delay, Stefan, please, it's okay if Sergio, can Stefan start?
Yes. Okay, so thank you, Ophir, that making this effort to join the meeting. Meanwhile, please, František, could you please share your window, your presentation? I would like just to introduce you shortly with all the titles, and then you can start. So, František is... One minute, František. Let me introduce you. Shortly, yes. I would say the idea to hold this meeting with František or with Eaton, that was born, let's call it in this way, during Emil's and my visit in Eaton premises in Vienna in a couple of months ago. We were hosted by František and team. That was a very, very good and professional meeting. And hearing and listening and understanding the capabilities and the technologies and the professionalism of the team, we understood that it will make very good impression, and it will be very valuable for our team, for our engineers in Israel, to organize and to have meetings with specialists from Eaton, and not only from Eaton, from all the other companies which are representing low voltage, middle voltage, IT, and whatever else. So František is a graduate of the Faculty of Electrical Engineering in Prague. It is holding an experience of more than 35 years in his field, holding position in laboratory testing, design of electrical installation, management of products at Möller, you know Kleckner at Möller, which is former Eaton, or Eaton is afterwards, after Kleckner and Möller was sold. Is part of technical committees of standards He prepares and presents application guides, design software, tools, and many other things. And once started, you will understand why all these positions are held by František. František, would you like please to start?
Okay, thank you for introduction. Do you listen me well? Is it okay? Okay, good. Then let's start with topic which you have selected. We can also look to another topics if it is interested for your next sessions. Topic for today is protection against creation of fire. This is something what you as a professional electric.
You are on mute, Stefan.
Okay, sorry. Then I have started with my presentation, and now it can be better. Do you listen me now?
Yeah. Yes, we can hear you.
Okay. Sorry for this inconvenience. Then I will start once again from this topic for today is protection against creation of fire. And we will look to some specific topics which you definitely know from your daily life. I would like to make such overview about problematic as we as company Eaton see it, because we are not, let's say, fire authority. We are a company which provides such technical solutions which can help in your projects or applications. If we look to agenda for today, we will shortly speak about causes of fire. We will look to details which are significant for creation of fire, and we will look shortly to protective measures like RCDs, AFDDs, which are also known on market. But what I want to mention especially is, let's say, some specifics of electrical installation standards, IC 60364, which you have in Israel as IC with the same number, then it will be easy for communication. And in the end, I will touch one very important new version of standard 60364-4-42, protection against thermal effects, which is valid from end of last year. Then maybe such overview about important topics will be good to mention. First, information where we need to be careful about fire creation is, of course, area of applications. Then we can look separately to medium voltage transformers, low voltage, and also cables and busbar trunking systems. My focus today will be mainly to low voltage installations now. And then if we need to discuss some other topics, we can also make such discussion during questions and answers. If we speak about fire protection, we need also to have very clear definition what we are speaking about. If it is fire prevention, or if it is managing of consequences of fire, then we will focus today only to prevention topics. Then I am not, let's say, looking to anything what is related to fire mitigation and so on. And also very important for correct understanding what we are speaking about. Don't make it like a very mixed topic like goulash. We need to understand if we speak about let's say protective measures which are focused to electrical protection, it means we will speak about use of protective devices, insulation materials, and so on. Or if we speak about existing materials or devices from perspective of thermal protection, it means if all materials are able to keep temperature limit and to be safe, yeah. And in the end, if we are in situation that we need to improve, let's say, resistance against fire of any component installation, we are looking to fire-resistant materials. Then this is a specific problematic which you know, for example, from cables or busbar trunking systems, where it is very hot topic during each project. Yeah, and only to let's say make it more formal, this split is not my idea. This is taken from one of standard. We can look to Vario splitting, but this is very useful for our understanding what we are doing. Also, if we discuss about way how to improve protection against fire creation, we need to know reason why we are speaking so much about it. The reason is number of fires which are in all countries, and of course statistics can be done in a little bit different way. Also, accuracy of numbers are not perfect and so on. But what we can say from various statistics globally, that there is a big issue in domestic installations, because it is a very sensitive topic for daily life for any people. Yeah? And what is conclusion from statistic? Plus minus 30% of fires in Europe or in other countries is based on electrical reason, yeah, some fault, some reason where electrical installation is used. Yeah, then we can see really big portion is related to electric installation. And also next topic, 50% of accidental fires are, it means when people are doing something wrong or ignore risk and so on, yeah, then this is, of course, the biggest portion, 50%, it's accidental. But we are electricians, and we are looking to those 30% of our portion, where we have chance to improve situation or not. It's dependent how, let's say, strictly we want to apply protective measures in projects or in installations. And also hard facts from such statistics, as we see, for example, from one source, from Forum for European Electrical Domestic Safety, and so on. You can look to other materials. Conclusions are the same, that most fires occur in family houses, and almost all are preventable, yeah, if we use proper materials or protective measures and so on. And it's possible to protect thousands of people in Europe against fire with minimal effort only. It means comparison human life and costs, yeah. And fire safety is addressed by building codes. It means standards, yeah, which fall under national jurisdiction. It means each country is using own approach. There is no common international standard for fire protection, but each country make own, let's say, rules. But common rules are behind the same. Very quickly, I will not read everything what you can see on this page. Something about fire statistics, you can see numbers. But once again, 90% of reported fires are in buildings. Yeah, question is if it is commercial buildings, or industrial, or family houses. We know that majority are in family houses. And 30% of fires have reason in electrical faults. and so on and so on. Then we can also make some overview about number of people who are killed annually. You can see thousands of people, and how many people are injured and so on, and how big amount of money it costs. Yeah, then this is such statistic background which people from fire authorities like. Yeah, it is their daily bread. But we will look to way how to improve quality of electrical installation. Yeah, then if we look to this picture, this is typical triangle which is used during each education. Yeah, how fire is created and conditions which are needed. Then every time when a fire is created, oxygen must be available, materials which can support fire, and also ignition source. Without ignition of fire, fire will not start. And then more questions are coming. What can burn? Yeah, how much current can start ignition of fire, and so on. Now we will focus mainly to sources which can create arc, and it's good to make in our mind such a scale of importance. Yeah, that overcurrents usually it is something what is part of each design. Yeah, daily it means overload and short circuit current protection. It's clear. Then next category of sources or reasons of fires are airs, leakage, currents, and the last one, which is discussed more and more, electrical arc, which can be the last ignition moment for creation of arc if all other conditions are fulfilled. Yeah, then now we will look to individual reasons, yes, step by step, to avoid situation which we see on typical pictures, which we know also from our daily life. For example, if some problem occurs, you can look to reason, and okay, in a good situation when fire was not developed yet to big fire, only local damage, you can see what was reason. Yeah, for example, not correctly connected terminal, for example, mainly, or wrong connection of various materials. Yeah, for example, aluminium, iron, aluminium, copper, and so on. Yeah, under conditions which are not allowed, for example, with high humidity, and so on. It means also various faults in outlet sockets, and so on. Fortunately, due to the fact that producers are producing all electrical equipment from materials which are resistant enough against fire creation, we can see in many situations that, for example, outlet socket is totally damaged, but fire is not created because this let's say hot point was limited. Yeah, then fortunately in some cases we can be happy that it is under control. And of course we can go to more details which are very critical. Yeah, in a normal installation, for example, faulty outlets and switches. This is typical situation in older installations. Yeah, lost connections and so on, damaged components. And also second category is problem with lightnings. Fortunately, year by year, by use of new technology with LED, it's much better. Yeah, with surface temperature and so on. Then also use of modern lighting sources help with reduction of fire risk. Yeah, then this is also good to take into account that some conditions for installation of flammable or installation of conductors or equipment on flammable materials will be not so strict when we use not so hot lighting sources, yeah, LED, for example. And here is this scale which I mentioned to keep it in mind. What is really important to take into account regarding risk of fire creation? Then usually overload, okay, we can relatively easily protect installation if we use correct overload protection and proper cross-section of conductors. Yeah, then this is I think without problem if it is done from beginning project, also during installation. This area is not so risky. Yeah, then we can see low risk from overload. Short circuit currents. Yeah, okay, we can discuss from movies, from Hollywood movies, everything is with short circuit current, and each short circuit current create fire, yeah, or explosion. What is not true? Yeah, because short circuit current, even energy during short circuit current is relatively high. It's limited by very some echo.
Who is under? Is it under? שיעשה מיוט בבקשה. תודה.
Yeah, it's possible to continue. There was some problem with echo.
Yes, please.
Okay, then I will continue. Then when we look to next critical parameter, it's air leakage current. It's something what is very, very important during design of installation to take into account, because there is only very small fault current available between phase and airs, but it affects, let's say, heating for longer time. Yeah, it is also named as creeping currents, and the problem is it's a relatively small current. For example, 100 milliamps or more looks like very, very low, but it can create fire during longer time. And in the end, something what is really dangerous when it is created, it means when arc between phase neutral or between phase ground is created, or also in serial connection. Problem with this kind of fault is that it is really difficult to detect such problem. And if this situation with arc is similar like air leakage current is present for longer time, relatively small arcing current can initiate fire. Yeah, then this is very, very risky, especially in places with flammable materials and many cables and so on. Yeah, then please make let's say in your head every time such scale of importance. And something what I think you know very well also from catalogs, product standards and so on. It's let's say categorization of materials which must be able to survive during higher temperature. Then this is something what we see in standard.
מאירופה על שריפה בלוחות. אתה רואה מה אני צריך לעשות?
Hello?
גם לשמוע את השקוף.
ישי, בבקשה מיוט, ישי.
Okay. hopefully problem is not on my side. Then when we look to various standards, we can make this conclusion. The same values of temperatures like 650 Celsius degrees, 750, 850, and 960 Celsius degrees are in various product standards. And it's good to understand why this scale is used. And also testing laboratories are doing tests according to, let's say, product standards, but rules are still the same. And we can take this standard EN 60695 and so on as let's say background of all product standards, and there is definition how glow wire flammability test is done. And important thing is, if we see testing temperature like 650, it is only for, let's say, some covers, construction, plastic, not so important. But when we use higher and higher temperatures, it is used for parts which must carry such construction. And the highest temperature, 960, it's a really high temperature. It's a tested temperature for parts, insulating materials, which must keep current carrying parts in their position, also during high temperature. Then you can see such plastic material which must survive such high temperature. It must be really, really good. And then it's such overview, I think, which we can use also in next discussions. And now separate problematic, which you also know, it's a problematic of low voltage switchboards, which are designed for installations where is required resistance to the effect of fire. Of course, we can discuss resistance of fire, which is inside or outside. Usually, switchboards are tested for fire, which is outside, yeah, but vice versa, it will work also from inside, because this design or special design of switchboards, which are certified for higher resistance against fire, are using such special materials which is used indoors or in parts which make barrier between, let's say, external part of switchboard and internal. And when we look to various standards, yeah, which we see here, dependent on situation what we need to test, we ask testing laboratory to make, let's say, testing of such combinations, and result is certification for example, 30 minutes, yeah, of fire resistance, like this. I don't know which system is used in Israel, because each country has also such deviations and so on, modifications. But what is here, it's usually, let's say, international approach with all IC standards or EN standards. Yeah, then we can discuss it later. And now, if we speak about fire prevention, we must also a little bit touch problematic of electrical testing. Then this is more a topic for installing companies, yeah, or panel builders. Then, okay, I will not speak so much about it, only to know that person who is doing such testing must be very, very familiar with purpose of needs. Then he must distinguish between functional testing, if everything works properly, yeah, safety testing, and also performance testing. Then various tests can be done, but purpose is clear, what must be achieved by such testing. And for example, one of testing method is RCD testing. Yeah, then this is something what is directly related to fire protection. And only to be linked to standards for installations, I would like to mention IEC standard. Okay, this is old version 61. Now we have one common version 60364-6 only. Inside are two levels: initial verification and periodical verification. Yeah. Then this is something what each, let's say, installing company use daily. Yeah. Then this is also part of fire protection problematics, and I will not speak so much about it, only to make overview that it is also present in our daily work. And now, very good topic for discussion. If such installation test is really applied for each installation, or which legal requirements are for various electrical installations. Yeah. Then, first of all, we must say that all international and national regulations state that all electrical equipment must be safe. Yeah. But how to do it? It's necessary to make testing, verification, and so on. It's relatively easy when installation is owned by company. Yeah, because it's relatively easy to make legislation for regular testing and so on. But problem is that in family houses, it's almost not possible. Yeah, because it's not possible to tell to owners of family houses, you must do something regularly. Yeah, then question is, what is mandatory and what is possible to do? Yeah, and important thing is, even if regular inspections are carried out correctly, there is always a risk of malfunction or fire. Yeah, then it's every time a problem of probability that something can happen. Yeah, we have never 100% guarantee that everything will work properly from moment of installation up to end of life of installation. Then we must look to protective measures which must be applied or should be applied. Yeah. Then we have currently two main, let's say, we have two categories of protective devices which are mentioned for new installations. RCDs with rated residual current 300 milliamps, almost for everything where is flammable material and so on, or 30 milliamps for specified heating elements. Yeah, then I will look on it later. And second protective device is arc fault detection device. I think you are familiar with this. We will look on it a little bit more in details. And if you or if any electrician wants to look to conditions, how to select or how to use those protective devices, it means RCDs or AFDD, we can recommend two standards which should be used, yeah, almost daily when people are doing let's say anything with electrical installation. It's standard 60364-4-42, protection against thermal effects, and next standard, very useful, 60364-5-53, devices for protection for safety, isolation, switching, control, and monitoring. And I would like to point out the second standard, 5-53. It's very, very useful guide for electricians to have rules for coordination, for selection of devices, and so on. Then really this standard is very useful. And there are also mentioned some other options like optical detection devices, smoke detection, and so on, which are dedicated for switchboards. I will mention it later, but now we will look to installations generally. Now, the mostly used protective device is RCD, which is usually used for fault protection, additional protection, and fire protection. And why this protective device is used as it is used? There is historically, let's say, historically, there was some research how to prevent fires in installations, for example, where we have such cables, mainly with PVC, polyvinyl chloride, yeah, which are the mostly used. The problem is with ultraviolet or with higher temperature and so on, they are created such damages on surface, and combination of dust, humidity, external influences, and so on, create creeping currents. Then with this creeping current between face and ground, for example, between face and wood, for example, is starting such local heating with thermal stress, and fire can be created. Yeah, and this is relatively simple explanation of problem, and it's also statistically done that from time when RCD was required as mandatory for fire protection, number of fires decreased. Yeah, then this is let's say well known. Many people can say obsolete, but still valid. And how it was selected, this 300 milliamps. There was done testing with many flammable materials, and there was a conclusion that the power dissipation of around 70 watts can create local fire. Yeah. Then after a calculation of 70 watts to current, there was fixed limit 300 milliamps. Yeah, as it is. And idea behind this described on this picture. In a moment when insulation resistance is going down, for example, humidity is growing, or some damage, then we need to detect this creeping current, and in one moment disconnect supply. Yeah, and usually it is 300 milliamps, but we can see also situation that for special cases, like in part 753 standard, or part of standard heating cables and heating systems, it's 30 milliamps only. Yeah. Something about RCDs, important thing is sensitivity, not so much other features like time delay or characteristic. No, in this case, it's long time presence of current, then only sensitivity is critical. Then doesn't matter if you use various types of design of RCDs like RCCB, RCBO, or combine RCDs for industrial applications. Yeah, what else? Simply this rated residual current is the most important parameter. And now, next part of this presentation will be about AFDD. I think it's nothing new for people, but we need to refresh some facts, because with new standard, which was published in the end of last year, like IC 60364-4-42, will be more cases with AFDD mandatory. Yeah. Then take please this information, like let's say such introduction to your daily professional life, where you must take into account new conditions of new edition of IEC standards. Here we can see such typical situations when cables are damaged or something happen, something happen with insulation. Then when we go to analyze, we need to understand in which cases RCD will react and in which cases will not react, and we must trust to AFDD. Then in such situations can happen bolted short circuit current. It's finally no problem. Overload device will disconnect. But if it is only arcing situation, it means serial arc or parallel arc, which creates relatively small values of fault currents. For example, 100 milliamps or 1 amp, something like this. A normal overload device will not react. Then we must trust to AFDD, and we need to know which protective measure is working or which will not work properly. Some historical overview. AFDD historically was promoted in US something like 20 years ago. Step by step improved. Abbreviation of US version is AFCI. It means arc fault circuit interrupter, and now it's mandatory in many installations. Of course, we can also see that the style of construction of family houses, for example, in US is dramatically different than in Europe, or in other countries, in Israel. It is also very important to understand why so strong demand is for AFDD in US. If we look, for example, to Los Angeles situation with fire, beginning of this year, you see majority of houses are wooden houses, wooden construction. Then this has also big effect to massive use of AFDD. In Europe, we need to use, let's say, the same principle of detection, but different design. Why? Because we are using different type of networks, we are using different loads, and also this create different scenario of fault currents. Then if you theoretically take such AFCI or AFDD from US to Europe, it will not work properly. Then we must simply take as fact that AFDD design must be prepared for, let's say, place of installation. And now something basic about standard for AFDD. We can see this standard number of standard EN 62606. And in this standard, we have everything what is important for producers, not for installers, or designers, for producers. And there are more variants which can be designed as single device, which combine everything, like we can see on the picture on left side. It's a Eaton version. Everything is in one compact design. You can see on the market also single devices integrated, or you can see separate units. Then everything is possible. It's still AFDD. In our case, when we speak about Eaton version, compact version, we use also this abbreviation AFDD plus, to express that everything what is important for protection is inside. It means MCB, RCD, and also AFDD. Then we can also distinguish between various producers, but in the end, result is the same. And now, very short explanation what we need to discuss when we speak about type of faults, and to know which protective measure or which protective device will work and which will not work. Then look now to colors. Yeah, I will start from top down. If we have overload in installation, this is this gray arrow. This is typical situation. It's overloaded or not. This can create fire. Second case, short circuit or parallel arc. It means this is fault between phase and neutral, or can be between phases also. Yeah. Then we have next situation. Fault is between phase and ground or earth. Yeah. And this can be also named like parallel arc if arc is created. Yeah. Then in this case, we understand well that this green scenario will be well protected by RCD. This red scenario will be protected by fuse or circuit breaker. Yeah. But what about this yellow case? This is serial arc. It means, for example, terminal is not well connected, or conductor is a little bit cutted. Yeah, then serial arc can be created, which is danger for insulation and so on. Yeah, creation of fire. But we know from electrical point of view, no MCB, no MCCB, no fuse, no RCD will detect this. Then only AFDD can be used. Yeah, and this is main reason why we speak about AFDD. And why we speak about it? Statistically, when we take fires where arc was origin of fire, 90% of fire reasons from arc are serial arc. Yeah. Then from opposite side, we can say only 10% of arc against airs are, let's say, in installations which can be detected by RCD. 90% must be, let's say, on site of AFDD. And now some overview. I will not speak so much. I think graphically it's very clear. If we compare various protective measures like MCBs, there is only short circuit protection. Let's say basic protection against fire is possible, but really basic overload, yeah, or short circuit. When we use RCCB or RCBO, we have this earth fault current protection. In case of RCBO, also inside is MCB. Then we have also short circuit protection, but it's still not enough. If we need to have full protection, it means overload, short circuit protection, earth fault current protection, and arc fault protection, then we need to use such combination, yeah, or as one complete device or separately. But to achieve this level of fire protection, all three devices must be included. Yeah. And now the same, only from perspective of functionality, the same what was on previous pages, only in a little bit different way to have it more clear. If discussions are starting, what is, let's say, possible to use, then if we have situation with fault between phase and protection airs or ground, it's possible to be protected by RCD or AFDD, but in this case, question is how big short circuit current it will be, can be disconnected by MCB or fuse or not. Second scenario, fault between phase and neutral, then in this case, dependent on value of fault current, MCB can react, definitely RCD will not react here. or RCBO can react, but definitely AFDD, in case ARC is created, will react. And the last scenario, as was mentioned, in case of serial ARC, only AFDD is able to ensure protection. Yeah. Then this is overview when some discussion, for example, with customers is starting, then some instructive picture is good. Yeah. And very short information. We can go to more and more details, but very shortly. If we have such a weak point in installation, like for example, almost cut it conductor, yeah, or pure connection in terminal, there will be such development of situation. In one moment, such connection will be disconnected, and here in this detail will be created ARC. And if ARC is presented for longer time, then carbonization of insulation is starting and so on, and then fire can be created. Yeah, then this is reason for this discussion. And now also very important question, how does AFDD work? Yeah, main idea of electronic detection is here on this picture. We can see it on the left side in this yellow rectangle. It's a situation when a serial arc is created, and in moment when voltage is not so high that arc can survive, yeah, will continue, then suddenly current go down. In one moment when voltage in installation is above such limit that arc can start, it will start with let's say negative effect to insulation and so on. Then this is exactly detail which is detected by electronic equipment. On the right side, we can see real record from oscilloscope where voltage and current is detected separately, and we see really this current has such discontinuity close to zero. Yeah, and this is exactly detail which is detected by AFDD part. And what is important, AFDD is a relatively intelligent product, because this is not only passive like MCD or RCD. This device has the biggest part with electronic, and this electronic part contains, let's say, detecting part like current transformers or voltage detection. Then there is such signal processing, where is evaluated form of current, voltage, and so on. Yeah, how it looks like. And one of the most important part of AFDD is evaluation circuit with, let's say, evaluation of a signal. And this is compared to stored data in memory. Yeah. Then this ARC detection module works like computer. Yeah, and simply compare incoming signal from signal processing module, and if it suits well to signals in memory, AFDD will give a tripping signal to mechanism. Yeah, then really reliability of AFDD depends on memory of this device, which is prepared by producer. Then result of good or not so good programming is that AFDD is well resistant against unwanted trips or not so good with this. Yeah, then it's also a result of long time of testing, tuning, and so on, and also let's say spectrum of signal in installation is changing. Yeah. Okay, next very important information is in standard for AFDD, and here we have such overview with picture and explanation. It's a so-called directional sensitivity, yeah, or in standard it is named like crosstalk test. What does it mean? If we have an installation in final circuit, like we can see on the picture on the right down corner, we see there is such arc generator, which creates, let's say, serial arc, and this frequency of signal is detected by AFDD, and this AFDD must switch off, yeah, this second. But if we use this arc generator for incoming terminals of AFDD, like this AFDD on left side, this AFDD will not switch off. It means AFDD must be directionally sensitive, and this is also tested that any signal which is coming from network or from supply side will not lead to disconnection of AFDD. Yeah. Then also it's related to reliability of evaluation. It's good to point out that reliability of evaluation of AFDD is dependent on number of loads on secondary or output side of AFDD. Then the best is to use very short sizes of installations or limited number of loads. It doesn't have big sense to use one AFDD for complete, for example, installation, because there will be very complicated, let's say, life for AFDD to detect a signal. Yeah? But on other side, we have no problem if such standard loads where are some higher frequencies generated. AFDD is able to work properly without unwanted trips. It means in memory of AFDD is fixed, for example, spectrum of signal from some devices, yeah, welding machine or drill machine or what else, electronic loads, dimmed loads, and so on. And this is acceptable for work of AFDD. Yeah, even we have such arc from commutator of motor, it's ignored because it's known. Yeah, then this is very, very important to know that it is a relatively intelligent device, not electromechanical only. And now, if we want to go to more details, only to understand conditions, how AFDD works, we can read all those numbers in catalogs, yeah, of AFDD generally. AFDD device is able to detect serial arc. We see it as green line. And parallel arc, and you can see standard for AFDD make definition for various values, and if we compare it with MCB, for example, we see that it's overlapping very well typical currents which are installations. Yeah, then we can compare it with existing devices, and it's, let's say, additional protection. What is also good to mention, AFDD is designed only for one-phase applications only. There is no standard for three-phase AFDD. Then, in case somebody need, or it's topic for each project. Yeah, if we need three-phase loads and fire protection, there is the only one possible scenario, use RCD. Yeah, because RCD can be used like 3-phase or 2-phase or 1-phase, but not AFDD, only 1-phase. And only for, let's say, overview, I will not comment so much. What is in standard for AFDD? It's good to mention one important thing. During testing, there is created ARC, yeah, AFDD is connected, and so on and so on. But standard describe conditions for so-called masking load. It means you have two problems for AFDD. Detect correctly serial arc or parallel arc, and additionally ignore masking frequencies. Yeah, for example, welding machine or such similar. And you can see that standard describe various locations. Yeah, then you can be sure that in normal installations everything is working properly, because AFDD is designed for various situations. And here we can see typical installation where we have combination of MCBs, RCDs or RCBOs and AFDDs. Then now question is, in which locations I will use only MCBs, RCBs or RCBOs and AFDDs. This is described in standard for thermal, let's say, protection. Yeah, it's standard 60364-4-42. We will look on it later. Then you can see typical situation will be or can be like on this picture. If you want to have very reliable and resistant installation with AFDDs, that you use one AFDD only for limited number of loads. Yeah, like we explained on previous pages. Yeah, then this is not only, let's say, wish to have it, but the behind is very logical reason to have reliable detection, yeah, and reduce number of potential unwanted trips. Yeah, and now very important topic, as was mentioned on previous slides, with directional sensitivity. Each AFDD has very strictly designed what is input and what is output. Yeah, then this is mainly for installers. Yeah, that it's not like MCB or RCD that you can change input output. No, here it's not allowed. Then installer must follow very clearly what is incoming, what is outgoing, and then device will work properly. And then very important information, input and output must be clearly let's say, specified in installation. Next question, which is coming from, let's say, user side or electrician side. How do I know the cause of the shutdown? It means I have such device like we can see on the picture, and I am not sure what was the main reason of disconnection. Then good to look to packaging of AFDD, yeah, because each delivery with AFDD is with user manual. Yeah, this is a simple page paper where you have all important available, and also all is done in way that you don't need to read any text. Yeah, then it is let's say language neutral. Yeah, then you can see what happened if you see indication of this indicator, what was the reason, and so on. Also this electronic part of device is able to detect what was a reason of disconnection with let's say, number of flashing of LED here. It's indicated reason of disconnection. Then you can see reason was serial fault. Reason was serial fault, which is caused by some device, or 3 times flash LED parallel arc, and so on, or over voltage, over temperature. Then this is relatively clear. If you lose this paper, it's available on my page, no problem. It's very easily accessible. And also next question, because you know very well, if you use, for example, RCDs, there is a request for regular testing. Yeah, of course, question is who is doing it, how often, and we can discuss how is difference between wish and reality. But this is not topic for, let's say, our discussion. Now we try to explain what is necessary to do to make everything in proper way. Yeah. Then if we look to functionality of such more complicated device like AFDD, which is connected to MCB and RCD, it's finally relatively complicated topic for regular testing. But what is good to know, each producer make such system of self-monitoring or self-test of AFDD. And for example, in our case, this electronic performs functional test or self-test each 24 hours. It means 1 time per day, it's done internal test that all circuits are working properly. Yeah. If you need to make testing of RCD part, there is available a standard push button, and after you test it or evaluate, you have evidence that it was or everything is working properly. One important topic, what is common for electronic devices during verification of installation with higher voltage measurement, it's necessary to disconnect AFDD. It's the same case like, for example, SPDs. It doesn't have sense to measure installation where is SPD, because it will not work. Yeah, this test. Then the same here. Electronic device must be tested in proper way. And question is, what about 3-phase circuits and fire protection? As I mentioned, if we look to standard for AFDD, it's only 1-phase solution. Then if we need 3-phase, the only what we can use is RCD. Yeah, this is like it is. And now we will go to part where we will look to conditions of standards for electrical installations. It means standard 60364. And let's say go a little bit more to details, which can help if you need more information. Then if we look to basic standards, which can help us regarding fire protection, we can make one, let's say, conclusion. There is no common IC or European standard for fire safety of buildings. Yeah, there are applied national regulations and laws. Yeah, then this is first common information. But if we look to safety of installations, yeah, now we will not speak about buildings, complete buildings, but installations in the buildings. We see we can open some of standards like 60364-4, 42, 43, 5-52, 5-53, and also parts for special locations. And here we will find everything what we need for new projects or new installations. Yeah. Separately, if we need to design new installation, we must be careful about selection of cables. Then here are mentioned basic standards for flame tests for electrical cables, also busbar trunking systems. Generally, if you are in situation that you must design installation with higher, let's say, fire resistance and so on, general approach is to use as much as possible busbar trunking system. Why? Because busbar trunking system contains less plastic materials which create, let's say, gases and which are flammable in comparison to cables. Yeah, then this is general, let's say, first moment when you have possibility to use busbar trunking system from fire protection perspective. Definitely busbar trunking system is preferable. But okay, if we use cables, we can select fire retardant or fire resistant cables and so on. Some examples of let's say fire cases which you can also find on internet or some publications. Historical buildings have special position in fire protection because what is historical, it's only one time available. Yeah? And this is very sensitive also for history of countries and so on. Then there is also special focus to personal to material protection and so on. Here we have, for example, one typical example which was discussed for a long time by fire authorities, Castle Hofburg in Austria, in Vienna, in 1992. Yeah, big fire, and finally one of let's say possibility was electric reason, but finally it was not fully, let's say, confirmed, and result is reason is not found. But you know, if such big fire happen, it's very hard to find real reason. But we can also look to some other cases, like we can see on the right side. In France, and there was very clearly specified electrical fault, yeah, as reason of such big fire. And now something about cables. Okay, it is not the main focus of my let's say presentation, but only touch it because it's part of design. Yeah. Then if we need to design installation in proper way, we must be also careful with correct selection of cables. We can see conditions in basic standards for electrical installations like part 443 or part 552. And yeah, if we select various insulation materials, we achieve also various fire resistance and so on. Usually we are speaking about such time like 30, 60 or 180 minutes. And if you want to work with such software, you have on right side one example with our software Xspider, where you can see also various type of insulations. Then you can select for your project different insulations, and also different current carrying capacity will be achieved. But okay, you are able to optimize your design also with proper selection of cable insulation. And now very short information about the standard 60364-5-52 53. I mentioned this standard is very useful, like let's say guide for each designer, installer, and so on, because there is a lot of information about the way of coordination, selection, and so on. And there is also one clause, it's 532, fire protection devices. If you look on it, you can see the same as we discussed. There, one of category are residual current devices. Also, current or residual current monitors, RCM, are inside. Insulation monitoring devices, it is mainly for IT networks, yeah, as you know, and also AFDD. But additionally, we can speak about other protective measures which are mentioned in this standard, yeah. And one of possible solution is use devices designed to provide protection in the event of overheating of such a part of installation or switchboard. Yeah. Second option mentioned in this standard, optically operated devices that provide signaling to another device designed to interruption of circuit. It means such a camera or detection of light. And the last case, smoke detection devices that signal another device to interrupt circuit. This is also something what we can mention in case of fire protection, for example, in switchboards. And here we have one solution which Eaton offered for many years, like let's say advanced fire protection. It's a so-called diagnose system, what is thermal monitoring system for low voltage switchboards. And advantage is that this system is monitoring 24 hours, 7 days weekly, and our system is working with wireless sensors. Wireless sensors are, let's say, here on this picture on the right side down. Wireless sensor is working like a transformer. If current, for example, in bus bar is higher than 50 amps and so on, there is generated enough energy for electronic inside of this sensor. And all communication is wireless, yeah. And each sensor has own address. Then it's a very, very clear definition of each point, which is monitored. And the result of this monitoring is that we can have monitoring of this, for example, switchboard remotely. And we see how temperature is on each sensor, yeah, and we see it also in relation to overload, yeah, and so on. Then this is something what we can recommend if you want to use, let's say, system which is designed for preventing of fire. And we can also see in standard for low voltage assemblies, standard IC 61439, it means for low voltage switchboards, focus very strictly to temperature rise limits. Then if we use such monitoring system, we can reduce risk to minimum. Yeah, then it is really recommended system for locations where we can be sure that there will not be problem with overheating and high temperature. And the last information, because also time is running, the last information is about one particular standard which I mentioned more times during this presentation. It's a new edition of IC 60364-4-42, protection against thermal effects. This IEC standard was published in the end of last year, and currently it is also available like harmonized document, and Senelec transferred this harmonized document to each members of Senelec. Israel is also part of this. And now national committees are working on localization, language localization. Then let's look to basic information which are related to problematic which I have presented so far. Then essential changes. If you know this standard, I'm sure you are working with this standard because it's part of 60364 group. Yeah. Then look only to changes. There is change in clause 426, and there is information about RCD protection against thermal effects. And there are more situations, we will look on it, which are described where RCD is used. And also what is a big change of this new edition, AFDD became mandatory for certain locations which are specified in next clause 426-4. We will look on it. And also, if you open this standard, you can see that there are also some national deviations. But when we open existing version, latest version, you see that there is not so many countries which, let's say, applied such deviations or were successful with this. Yeah, you can see Austria, Switzerland, and so on. But also, when I speak about my country, Czech Republic, is not here, and Israel is also not here. Yeah, then what does it mean? All, let's say, conditions of this standard will be mandatory in our countries. Of course, there is such a time when old standard will still be available and new will be validated and so on. But to be sure, what is necessary to do in new projects, I highly recommend to look to this standard in the moment when it is published, yeah, in Israel also. And then look especially to this paragraph 426-2, protection against thermal effects caused by insulation failure. And here it's mainly focused to RCDs, yeah. And there is description in case of RCD is used in TT, TN, or IT systems. They must be used, let's say, generally 300 milliamps as so far. Additionally, there is also mentioned case of insulation failure. In case of some situations like heating element on sailing and so on, then this is a little bit extended against the current version. And additionally, in IT systems or IT network systems, there is necessary to use insulation monitoring device and insulation fault location system. Yeah, then this system we know, for example, from hospitals where this system is used for many years. Yeah, by some companies it is offered as standard. Now it is mandatory. Yeah. And also good to know that one RCD can be used for more circuits. Yeah, then this is good to know. Not for each, more can be combined. Next paragraph 426. Only very short information. There is mainly focused to final circuits where arc fault is potentially created. Yeah, then we have conditions that it is focused to outlet sockets and final circuits. Then it is separated because risk in outlet sockets is every time higher. Yeah, but definitely we look also to final circuits because problem with damage, for example, of cables in family houses or in some locations is very high for final circuits. Yeah, for extension cables mainly. And here is clearly mentioned duty to use AFDD. And now we need to know what will be as named locations where AFDD should be used. Then so far it was relatively limited and also recommended, yeah, use of AFDD. But in a new situation, it is mandatory in all countries. There is no national deviation. Yeah, and here it's only copy-paste information from standard 4-42. Then only look through very quickly, and maybe you can be surprised how let's say how high demand for use of RCD and AFDD is in new standard. Yeah, then look where RCD and AFDD shall be applied. Point A, locations intended for people to sleep. Why? Because majority 70% of died people in family houses is during sleeping. Then this is direct result from statistics. Yeah, locations intended for people to sleep in. And here is described where it is hotels, guest, education, blah, 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 blah. Then practically everywhere where people are sleeping. Point B, locations intended to be occupied by a group of persons like elderly or disabled people, or also elementary educational and kindergartens, and workplaces in high-rise buildings. Then you can see really everywhere there is high risk from fire. Next group, locations intended for storage of either flammable materials and so on and so on. It means this is everywhere there is higher risk of creation of fire. It is also classified by external influences, BE2, in facilities for the elderly and people with disabilities, hotels, guest houses, elementary educational establishment, and so on. It means additional demand. Look, point D, locations intended for storing of irreplaceable goods and so on, can be like historical buildings, as was on the picture on previous page, museums, libraries, and so on. And as before, historically, agriculture premises where livestock are kept, it's also part of, let's say, higher interest of protection. Then this is such overview. You can see it's very heavy, heavy demand for use of RCD and AFDD. Then it's necessary to think about it in new projects when new standard is applied. Yeah. Then it's end of my presentation. If you have any questions, now we can go to, let's say, questions and answers. Then please share your screen if you have something for discussion, or I will use my screen when I need to answer something.
Thank you very much, František, for the for the excellent presentation. We have learned a lot about measures for mitigation against fire risk. I would like to invite from the audience questions. I will start, please, with Danny Weissman. Kindly, please. I know that you would like just to ask something. František, please. You are on mute, Danny. Danny, you are on mute.
Thank you. My name is Dan Weissman, and I have a question, general question. You mentioned on your lecture that electrical origin fires are about 30% of the total fires. There is any split between domestic and non-domestic fires?
Yes, but it is really dependent on let's say country statistic. I will go back and maybe make some comment to something like this. Look, I
Yes.
can, let's say, once again touch some information with some comments. Yeah, for example, if I use this document, which is very serious and very, let's say, complex, but if we look to premises of, for example, of this document, there is information that it's focused to commercial, to some family houses, but don't split some details. Yet, and such result is also with some unsure information. If we go to another sources which we use, for example, during preparation of our materials, we focused a little bit more also to commercial buildings, but also when we look to, let's say, German statistics, Italian statistic, or Czech statistic, we can see sometimes it's not the same approach. Simply, this is dependent on approach of local fire authorities. Yeah, what they keep as important. Yeah, then sometimes you can have much better information from your authorities, from some segment, than, for example, from other. But in the end, our experience is that so far, nothing is so perfect that you can take one country like gold example of everything. No. Every time is play with various numbers. For example, if we speak about 30% of fire in buildings, if we look to German statistics, they split it in various ways, and they are speaking, for example, about 24% in this case, 27 in this case, 20%. It means, the question is what we can take like conclusion. If we look to British approach, in many cases, they show, for example, 40%, in some cases, 40%, but also dependent on way how it was evaluated. Yeah, then this conclusion, what we can see is such, let's say, average result from reliable sources, let's say. Yeah.
Okay, and the question is regarding panel boards and switchboards.
Yeah.
What is their contribution of electrical fires?
Generally, when we look to this, because we also produce switchboards, yeah, there is not so many real fires inside of switchboards. Really, there is not so, but we see a lot of damages, serious damages on terminals of devices, and this part can be, let's say, initial moment for creation of fire. But we also know it's also related to correct or not correct selection of insulation. Yeah, because if, for example, panel builder use cheaper PVC insulation for switchboard, and this problem start, PVC is partially flame retardant, but when you still have source of temperature, fire will continue. Yeah, then in the end, there is not so many cases in real situation, also due to fact that standard approach is to use as best as possible insulation materials, as was mentioned on one of picture. Just a minute, I will, yeah, here, look here. This is, I think, the most important difference. If switchboard inside will have problem with creation of fire or not. If insulation materials are selected from higher category, there is dramatically less problems with creation of fire. Simply, higher and higher category, for example, 850 or 960, are so strong that they will be okay. Damaged mechanically, they will be destroyed, but they will not create any fire. Then majority of cases is also wrong selection of insulation.
Okay. May I ask another question also? It's a practice here to install smoke detectors to detect fires in the switchboards.
Yeah, can be.
And also to use an automatic extinguish system that is inside the switchboard to extinguish the fire. What is your opinion about?
Okay, this is something what we are discussing also, for example, with some customers in Norway in exactly the same topic in those days. And it looks they are fully happy with solution with smoke detectors. Yeah, we discussed, yeah, what else is needed and so on. They told, yes, some let's say system of extinguishing of fire and so on is used in super special situation. This is, for example, used in submarine installations, super special, but not in normal installation, because if such sprinkler, for example, is used, it's finally end of all components inside. Second option can be use of such inert gases, yeah, but this is very expensive and not used. In the end, not used. Then main focus of customers is, okay, if we want to increase dramatically safety in switchboards, let's go to selection of proper materials to be sure, proper insulation of cables, make correct initial and let's say periodical verification of connections. It means torque of each terminal. And like the last, let's say the most expensive, to install smoke detectors, but not more. This is our experience from Europe, from Middle East, where we are discussing this. Okay, now Eaton is working on such a, let's say, type of smoke detector, which should be like device fixed on thin rail. Yeah, there is such patent behind and so on, but still not available for sale. Then in moment there is such progress, I can inform our colleagues. But in this moment, yeah, we know about it. So far, only Norway and Israel is asking for this. The rest of countries are doing like in Germany, France, and so on. Let's say proper materials, check of terminals, and check of hot points in switchboard. And this is taken like enough.
So actually, it's more important of the prevention.
Yes.
To arrive to situations that you have the fire and then you have to distinguish the fire.
Exactly. And this is exactly case which I mentioned with this, for example, system like this. we have this diagnosis system for continuous temperature monitoring, and we know how hard is to persuade users to use it. And this is one of typical example of continuous monitoring of critical points. You can fix those detectors of temperature on bus bar, on terminal, somewhere. Simply select critical connection points, yeah. But it's a very hard discussion with end user or with designer to use it, because it's additional cost for switchboards. And there is in Europe, Middle East, there is no other demand for this. We see it on this example. Yeah.
Okay, thank you.
Yep.
Any other questions, please, from the audience?
Yes, I have a question. Hello, I'm Shlomi from Arcoin Engineering. You show in one of the slides the integrated device that include RCD and AFDD in the same package.
Yeah.
Can you elaborate on the type of the RCD? Is it type AC, A, B?
Yes. I can very shortly explain. Maybe the best is one picture.
Also about the short circuit capability of the device. Is it 10 kiloamps or?
Yes. Look on this picture, and from front printing we can read all important features. Yeah. Yes. We have more variants. You can see, for example, this device has MCB part with 6 kiloamps, for example, yeah, braking capacity. If we look to rated current is up to 40 amps, yeah. If we look to middle module, you can see symbols show A-type, yeah, A-type. Also temperature, okay, it is information -25. And regarding non-actuating time, 10 milliseconds, we are using G-type. It means super high immunity against unwanted trippings. Yeah. Then you can see this is part of RCD, and AFDD is according to characteristics which I promoted. Yeah. Then there is no surprise regarding MCB. It's standard. Yeah. RCD is A-type standard, and yeah, we can see here a little bit bigger yeah, picture. Then only AFDD and characteristic is in presentation or in catalog. Yeah.
Are Eaton Israel are prepared to launch these devices for the Israeli market?
It's the same. It's what we use. It's tested also in Middle East and so on. Then a system of installation is very similar. It means you are using TN mainly. Also, typical loads are the same. Then, in case we see some, let's say, need for modifications, our innovation center in Prague is responsible for next development or update of software. And then, let's say, when installations will be different in 5-10 years, also firmware inside will work with different setting. Yeah.
Shlomi,
also... yeah.
Sorry, Franta, just to answer Shlomi's question. So the answer is yes.
Yes.
These products are already available.
Yes.
Already available for the Israeli market.
For 4 or 5 years. Yeah.
Yes. They will be available, but the current AFDD is already available.
Yes. Everything. What is important to say? I mentioned one important moment. It means resistance against unwanted trippings. I can go back here. For example, here. We must say, if we compared, for example, various products, also from competitors, I must say, because I was in such time directly interested in results, how progress is in development and so on. Then I really was positively surprised how great job our developers made with our AFDD, because Okay, we must say some companies were a little bit faster on our market with introduction of their separate devices, but we were, let's say, we were laughing, yeah, in Eton, that they offered such devices, but it was blocked for sale. And information from our R&D was, yes, we know why. Because they have serious trouble with not correct, let's say, behavior. A lot of unwanted trips. Yeah. Then what was for me very good message. Even we were delayed some months behind our competitors. In moment when we promoted our type, it was regarding unwanted trips, really the most advanced, because this is indicator of real reliability, not only functionality that this device will follow such conditions for serial parallel arc. No, this you can have from any product from China, no problem. But problem is here. It means very high resistance against unwanted trips from spectrum of frequencies which are in your installation. Yeah, then I can say, based on my experience from our team, we have really very good result from this, and our team is still working on it, because also type of loads is changing, type of installation is changing. Yeah, then what was valid 20 years ago and now it's absolutely different situation. Yeah, then development is continuous, but in this moment we can be absolutely sure that Eton AFDD is one of the most reliable on the market. Yeah.
Another question, the last one. What will be the best way to install this integrated device in a simple residential apartment? So basically here it's mandatory to use RCD. So we put at the incomer, we put a common RCD, let's say 4 times 40 amps. Is it going to be okay to use RCD including AFDD?
Finally, yes. Look, each outlet socket which you have in your family house must be protected by RCD. Question how you use it or how you install it, if it will be separate RCD and so on. But logical step is, if you use AFDD, for example, for sleeping room or children room, yes, it means limited number of rooms, it's enough. Yeah, then use here this combined device, which has also this function of overload protection. It means protection of conductors, protection against electric shock, yeah, and AFDD like protection against serial and parallel arc. Then use it, for example, for 2 rooms, and it's okay.
No, I was asking maybe to put it for all the apartment, maybe to put it here, one integrate for all the apartment.
This was what I mentioned. Yes, you can do it, but look, it's available only like one phase. Yes. You can also combine more circuit which are supplied from one phase and save money. But problem is with, let's say, reliability of detection. This is one problem. And second problem is, if this AFDD, which will be used, for example, for 3 rooms, detect such problem and disconnect, you don't know in which location this problem is.
Yes.
Yeah. Then this is on one, of course, it's on one side question of money. On other side, let's say comfort, or you know the same like with RCDs. If you use one RCD for family house, finally no problem. Yeah. But if you have bigger and bigger house, or you have outlet sockets outside and so on, then you are in troubles to find fault point. Yeah, then we let's say recommend such gold middle way. Yeah, to use everything as you are using, but use AFDD for example, sleeping room and a room for children, and it's enough. Not necessary to do it like here, bathroom, forgot on it, yeah, other rooms, simply where you are sleeping. Because as I mentioned, 70% of died people is during sleeping. Okay.
Yes, thank you.
Yep.
Thank you very much, František.
Yeah,
Really enjoyed your lecture. It was concise, very clear, very precise. And we, in name of all the audience, I see you have a large audience, even though at this late hour, from our point of view, it's already 6 in the afternoon now in Israel. So wishing you a very pleasant evening, and also to those that attended the meeting.
Yep, thank you.
Can I ask one more question?
Yes, of course.
It's not about AFDD, but you mentioned...
Okay, I would like to close the meeting now. Excuse me, the meeting is closed.
Please send me email if you want, or we can continue
send the email. Okay.
one-to-one.
Bye.